I'm Colin Walls, and I'm here once again to talk about embedded software. Today I want to talk about file systems in embedded applications. Historically this just wasn't an issue, but increasingly it's something that developers need to be thinking about. To know this subject, let's review how memory is used in embedded systems over the historical timeframes, but also over the range of different kinds of systems that are built today. In the earliest days of embedded systems, it was very simple. We had some ROM of some kind, probably PROM, but some kind of read-only memory anyway, and a certain amount of RAM. And the ROM was used to store the code and the constant data, and the RAM was used to store variable data. Very straightforward. This was very nice because the system would start up very quickly. It was fairly hack-proof, had lots of advantages over other possible technologies. Time moved on, and the next architecture we began to see was similarly the code and data stored in ROM, but a much larger RAM area. And what happens, and this is now, I say, very common, is copy from the ROM, which is typically flash nowadays, and copy that into the RAM, and then execute the code from RAM. Why do we do that? Simple is execution time. The access time of memory is quite variable. RAM is fastest. Therefore, if you put the code in RAM, it runs faster. The downside is the startup time is longer because you've got to copy that data across, and there is sensitivity to power failure and things like that. So it has pros and cons, but the big advantage is performance, and that overcame all of the other drawbacks. Now, many years ago, computers used to have memory which was non-volatile. So you switch a computer off and come back to it the following day and switch it on again, and the data would still be in memory. Well, those days are long gone, but we can still have non-volatile RAM when we need it. So a technology which is often applied now is a small amount of non-volatile RAM is added to the memory map. So we go through the same procedure. We have data in ROM, we have code in ROM, all that gets copied into RAM typically, but some data is kept in non-volatile RAM and therefore will persist through power cycling. Non-volatile RAM requires special programming. You have to be careful to check that its contents are intact and make sure they've been initialized. That isn't too difficult, but it's something you just have to think about a bit. That's fine for many kinds of embedded systems, and it's a very common architecture. However, with the increasing use of operating systems like Linux, where a file system is necessary, we need to rethink things. Now, a file system normally lives on a disk drive. We don't normally have disk drives in embedded systems, so of course we use flash instead. So the architecture now would look something like this. We'd have a large area of non-volatile RAM, so flash typically, and a pretty large area of RAM. Code and data would be read from the non-volatile RAM into, non-volatile RAM into RAM and executed from there, and other data is pulled from the NVRAM area as and when necessary. The best way of organising the NVRAM area is to make it look like a file system, much the same as on a desktop computer. This fits in exactly with the way Linux wants to work, but can also be done from real-time operating systems like our Nucleus product, where a file system is an option which you have available. The file system, I said, was a bit like you have on a desktop computer. It's not quite the same. It has to be multitasking, multi-thread compatible. It also has to be resilient to power failure. So if a power failure occurs during a read or a write, it shouldn't completely trash the file system, of course. And these are characteristics which are often looked for. And also, security using encryption techniques is also something that many developers need for embedded systems with a file system. So it gives you an overview of what file systems in embedded applications are. They're by no means universal. If you're using Linux, you have no choice, but for other operating systems, it is an option. And for now, that's all I have for you. So until next time, bye for now.